and today we'll be going over transformations. This is iBuddy Math Grade 10. Sorry. This is going to be a very compressed unit. Everything is going to be self-explanatory after this. It will essentially be a mix of many different transformations, and hold what mostly comes after this is your own exploration of this unit and essentially understanding of the lesson. Essentially molding everything I taught you together and combining them. It's pretty simple actually. So you'll probably get the gist of it. Let's just get right into it. So word transformations, they're mathematical alterations to graph size or position. You don't need to know this definition, just say it's a transformation. Right, it's often represented by gx equals a f b x minus h plus k. So, first off, not get hyperfixated on these numbers. They don't mean anything. A, B, H, K, I've seen A, K, D, C, I've seen any other combination, and they don't actually have any real meaning. They're just a placeholder for the numbers. The numbers themselves and their position have meaning, and that's essentially what it means, right? So regardless, for communication reasons, I'm going to be splitting them into A, B, H, K values, and it should be pretty easy to understand through this. So first off, I'm starting with the k value and I'm ending with the b value in terms of difficulty. So the k value vertical shift is the easiest. We have these 5 points that are very visible, and essentially just move them up by 5, each and every single one of them. Move them up by 5, and up by 5, and this we move them up by 5. And now we have this. So that's the k value. You just move everything up by 5. There's no nuance to it. There's no difficulty to it. You get the coordinates, you plot them, and then you essentially shift them up by 5. Now, this is the h value, the horizontal shift. Now, this one's a bit more difficult because there's some nuance to it. Because this is x minus h, let's just visualize that. X plus 5 equals 0. This is essentially what it means. And so x must equal negative 5. So this is where the confusing thing comes in, because if it's x plus 5, it's shifting 5 to the left, which means that it's essentially opposite. If it's x minus 5, it's shifting 5 to the right, which is a very deep contrast to say the k value, when, well, positives and negatives mean what they mean up and down, right? So let me just do this one real quick. We have these values plotted, and sorry, I'm just going to skip this one because I know it's not going to fit. We have this here, we're gonna have here, here, and here. Now we plug this in, and boom, we got the function. This is essentially transformed, moved, shifted 5 units left. Now the a value, the vertical stretch. Let me clear the page real quick. The vertical stretch is essentially a reflection of the y value of each coordinate. So that might seem like a mouthful at first, but let me just plot the coordinates. And well, first off, we have 1, negative 1. We have 3, 3. And we have negative 1, 3. Now, there's a reason I'm not plotting this. And you'll see in a second why. But we're going to take each of these y values. I'm going to multiply them by 2. Right? Each and every single one. I'll multiply them by 2. And when you really look at this, the y value for these two is just 0. So it doesn't really matter. Now, we have 3. It'll be here. 3 will be here. And negative 1 will be here. So this is a perfect parabola. First off, draw your parabolas better. I'm on a computer right now with a mouse, so this isn't necessarily the best parabola. Your teacher will take marks off for this, by the way. This is a parabola. It has to look like one. So that's essentially how you do the vertical stretch. But there's another stipulation. It's that if it's a negative a, it flips it across the x-axis. So let me demonstrate. Let's say we have negative 2 of x now. And we have these same 3 points, right? Negative 1, 3, and 1, negative 1. And now we do the same thing. We multiply each and every single one of them by negative 2. So these two will be negative 3, but I won't have a place for them. So I'll plot them down here. And negative 1 will be positive, negative 1 will be um actually positive 2. So we have this, and we connect this, and boom, we have a parabola that seems to be flipped over the x-axis. So that's where this comes from. It's a pretty simple concept to understand. Doing the same thing, it'll get you the same answer. You don't really need to consider it beforehand. Now we have the b value, the horizontal stretch. Now the horizontal stretch is essentially what we did here with the y value, but for the x value. So we're going to plot the same points, and this time we're also going to plot this because, well, you'll see in a minute. 0, 0. This is 1, negative 1, 3, 3, negative 1, 3. And instead of the y value we're multiplying, this time we're going to multiply everything by the x value. So we have 2, negative 1 here, 3, 3, that would be 6, 3, 2, 0, that would be 4, 0, 0, 0, that would stay there. Negative 1, 1, that would be negative 2, 1. So this isn't very conducive to being clear, but you'll see as I go through, it's almost as if it's stretched by 2. Almost as if it's stretched by 2. So this is quite peculiar because, well, it is stretched by 2. So I suppose there is some truth to that. Well, you keep the y values the same in the b, and you keep the x values the same with the a. So that's how everything works there. This is essentially everything. You have the vertical shift, the horizontal shift, the vertical stretch, and the horizontal stretch. So now you can list transformations, every single one of them, and you can list them. So we have the forms here. And how do you list the transformation? Well, this is a transformation as for a parabola, as you can see here. Now we have negative 3, negative 2, and 4. First off, you should realize that there's no b value, so immediately cross that out, which means that there's no horizontal stretch. Now, there is a reflection over the x-axis, reflection over x, and we also have a vertical shift, vertical shift up 4 units, and oh wow, we also have a horizontal shift right 2 units. Okay, I'm sorry if you can't read this, but just bear with me. And you can't forget the 3. First off, I made an error here, and it's that these two should be down here, and I believe the vertical stretch by a factor of 3 should be up there. So it's a vertical stretch by a factor of by a factor of 3. That's all you need to write. By a factor of is a valid term that you can use in math, which is quite surprising, honestly, because there aren't many acronyms that you can actually use. So this is all you need to list transformations. You look at the number, you decide what transformation it is, and then you list it. It's that simple. And that essentially concludes transformations, IB Math Grade 10.